All right, last time we started working on the chain rule, and we had done quite a few examples, and we ended with an example number 6 right here. Yeah? Okay, cool. So we're going to jump back in with example number 7. Our directions in this problem say to evaluate the derivative of the function at the given point, and then use a graphing utility to verify. And I'll remind you how to do that too, so if you want to grab your calculator out, we will need that in just a moment. So evaluating the derivative simply means to find the derivative and then plug a number in, right? So we're doing the same thing that we did on the previous problems, but we have a whole bunch of more rules than we had when we first were doing this process, because we have the product rule, the chain rule, the quotient rule, and a bunch of trig rules too that we didn't have before. So on this one, there's a couple of different ways to do this problem. You can approach the problem as though it's a quotient, and that's okay. You can do that. It's not really what we would consider mostly a quotient because the numerator is just a constant. So the way that I would approach the problem, because I think it's easier, is to take that x cubed minus 2 and write it to the power negative 1. Okay, so this piece at the end is just our point that we use at the end. It's just sort of sitting there for the moment. Okay, so that's the same original function that we started with. So somebody work with me and tell me what would you get for the derivative of this function using the chain rule? Yeah, and then it repeats the inside, right? We always repeat the inside. And then what's our new exponent? And then we'll multiply by the derivative of the inside, which is what? Yep, 3x squared. Now, you might be tempted to think this problem's kind of just as ugly as all the other problems, and I clean it back up, and you can. And in fact, on this one, it's not too bad. But there are cases where plugging the value in without even cleaning it back up is actually easier. So don't feel like you have to put it back in its nice, pretty form that it began with on this problem, because that's not really where you're ending up in the problem. Your goal eventually is to plug this number back in. So on this case, the number negative 2 to plug in isn't going to really help us either way. Like, it doesn't sort of just scream, hey, just plug it in right here, or hey, clean it up. So I am going to clean this one up just because it has a negative exponent. That's really why I'm going to do it, is I want to put that back in the denominator. But the piece at the beginning and our piece at the end can be combined. So I have negative 15x squared. And then I have x cubed minus 2 to the second, or squared in the bottom. Okay, so that's the derivative in general, but we want to find the derivative at the value of negative 2. So I have negative 15 times negative 2 squared over negative 2 quantity cubed minus 2 squared. So let's do some simplifying. On top, what's negative 2 squared? 4, and 4 times negative 15 would be negative 60. Good. All right, denominator. I have negative 2 cubed, which is negative 8. Good. And then negative 8 minus 2 more would be negative 10. And then negative 10 squared would be 100. Good job. And this is negative 60 then over 100. It will, in fact, clean up pretty well to what? Yeah, negative 3 over 5. Okay, so that's our answer. Let's use our graphing utility to verify, because I want to remind you how to do that. It's always a good tool to have. Okay, so what you're going to do is you're going to take the original equation you were given, in its original form even, I would anyway, and you're going to plug it into y1. So you've got 5 over x to the third minus 2. Okay, that's plugged into y equals. And then in your regular screen of your calculator, the blank old screen with nothing exciting going on there, you're going to do math 8. Math 8 is in deriv. You're going to tell it what the function you're using is. It's y1. You're going to tell it the variable that you're using is x. And you're going to tell it that you're evaluating it at the point negative 2. And I know there's 2 different versions of how you might be entering that, but we've done that a couple of times now, so I hope that's okay. And our goal is to get a value that's equivalent to -3/5. Does your calculator do that? -0.6. Mine too. And it's got some, mine anyway, has some weird decimals at the very end that don't exactly round off to -0.6. Just a reminder, that's normal. Your calculator's not really using calculus to do this problem. It's using numerical methods to do it. So it's okay that there's this sort of weird error thing at the end going on, and it's not a problem. Okay?
You plugged in the first equation, and did you plug in the second one as well?
Nope, I didn't. I just plugged the first equation in, and then I did math 8 in the regular screen.
Oh,
Do you remember that?
and then Y1.
Yep. Y1, x, and -2. Okay, any questions on that one? Okay, one more example in this section. It says find an equation of a tangent line to the graph of f at the given point. That's the first thing. And on the second part where it asks to use a graphing utility, we're actually going to use a graph on this one because we're actually finding an equation. Okay, so the graphing utility part of the instructions are a little different than the last problem. The last problem was just evaluating it at a point, which we could do that with this problem as well, but that won't actually verify that our equation's right, and we'd like to verify that the equation we get's right. So, starting with finding a derivative. What is the derivative of 4x cubed plus 3 squared? Okay, we're going to get that at the end, but start with the part that's the 2 outside first. Yes, the 2 to the front. Put everything that's in the parentheses. And it's not very exciting to the power 1, but we'll write it. And then, what did you have after that?
12x squared.
And it's just 12x squared, yeah. Okay, so this is one where, I mean, you can clean it up if you want to, but there's really not much of a need. I can plug the number -1 for x in here just fine without ever doing any cleanup on this one. So that's what I'm going to do on this particular problem. So I've got a 2. I've got 4 times -1 cubed plus 3. I'm not going to write the power 1 because we all know that that's not valuable at this point. I have 12 times -1 squared. Okay, so I'll clean up just a little bit as we go. I'm going to leave the 2 here for the moment. -1 cubed would be -1 times 4 is -4 plus my 3 is, yeah, -1. And then on the end, I have -1 squared. Right? So that's 1 and times my 12. So I just have 12 at the end. So I have 2 times -1 times 12, which would be -24. And if you want to confirm that -24 is the right value here, you could use deriv. That'd be okay. But what we're asked to find on part A is to actually find the tangent line. And the tangent line means that I need to use that slope I just found plus the point -1, 1 at the top. So one of the versions of our lines that I mentioned last time was this one, so I'll use this one this time. If you want to use y equal mx plus b, that's totally fine too. But this is y minus the y1 value, which is 1. M is -24. And then x minus my x1 value, which is -1, like so. And I need to clean this up. So I have y equals, it's like -24x plus the 24, sorry, plus the 1, so -24. And then I've got that 1 over here that I need to add on to it, so it's actually -23. Is that all right? Okay, so on this one, because I have an equation of a tangent line I'm trying to verify, I'm going to take the calculator and I'm going to plug in the original equation. So you're going to plug this in right here into y1, and I'm going to plug the slope, well, the tangent line, actually, that I got into y2. And if you're wanting to know, like, what window should I start in, I think I've said this before, but I usually just start with a standards window, which is Zoom 6, and then manipulate if I need to. That's not a great window for sure. My window's very skinny. The graph is very skinny, so I'm just going to make my window narrower. So if I make my window, say, from -5 to 5, that should help on the X values. And it's not too bad at that point. It could be better, but it's not too bad. The sketch, that's what you would do for part B, verifying it with a graphing utility. You're going to show me what your graphing utility showed you. So if we take this one, I have a graph that looks something like this. And I'm curious about the point at x equal -1. Again, my scale's not great, but here's -1, 1, so it's about right here. Okay? And it does, in fact, look like that the line that it's drawing on that, on my calculator, seems to be about right here. That pink is terrible. I gotta do something different. How about a darker purple? So it looks something like that. So again, the verification is a visual verification that it seems reasonable. If the graph had drawn instead something that looked like this, right, or even if it had been through the point but it looked like that, that should raise red flags and say, I did something wrong. This is not what I should have gotten, okay? So you're just verifying that visually it seems reasonable. Any questions on that? Okay, I'm going to leave the video recording so that you guys can hear about the gateway and go back and listen to this if you need to, or I know we have a couple people gone today and they'll be able to hear it as well. So you're going to be doing a gateway for me next class period. You've got the homework, everything's the same, 2.4, none of that's different. But you're going to be doing an extra quiz, and it's a different type of quiz than we've done before. I mentioned last time there will be 20 questions, and all 20 questions will simply be find the derivative. Find the derivative. When you have more than one way to do it, you can do it in either way possible. I don't care. So there's a couple of things you need to be aware of. Number one, you will not have your calculator with you. The reality is that it shouldn't be able to help you with actually that question anyway. Okay? Number two, you don't have to simplify anything. Nothing at all. So on these ugly problems, I mean, and we had some ugly ones, right? Like, you leave it as that very first line, yeah? You leave it as that very first line. And there's actually two reasons for that. Number one, the point of this quiz is to test the calculus skills that we're working on at the moment, okay? We work on algebra with all other sorts of things, but this is to test the calculus skills that you've been learning. Secondly, it's a lot easier for me to test your calculus skills if you leave it in its ugly version, because I can find all the pieces there, okay? So how does the quiz work? Well, we'll take about 25, 30 minutes, something like that at the end of class, and you'll do the quiz for the first time. 20 questions, absolutely right or wrong. If you miss a negative sign, it's wrong. If you miss a 2 when they should have written down a 3, it's wrong, okay? So it's right or wrong. So you should definitely go back and check your work when you're done. I don't say that to intimidate you. I say that to mean the fact that what we're doing is really important, that you do it correctly. And even little errors in derivatives are going to cause problems for us in big ways later on. So we got to get it down perfect, all right? Also, because that is a hard task, doing it perfectly on every problem, or at least 18 out of 20 of them, you have the opportunity to retake that quiz. So if you take it the first time on Tuesday and you get 18 right, 19 or 20 right, then you get bonus points. You get 55 out of 50 points possible. If you don't get 18 questions right, then you will be finding me in my office. Some of you have already found me in my office, but not very many of you. You'll come and you'll visit with me in my office. We'll go over your old quiz, and then you'll retake another version of the quiz. And there are lots of versions of this quiz. So you can come in every single day for 2 weeks after I give you the results back. So Tuesday we're taking the quiz. You'll have the results no later than Thursday class period next week, and then you'll have 2 weeks from that Thursday. So pretty much you'll have till I think that'll put us at the week before spring break, or is that, am I off week? Let me look at the schedule. So we're doing the gateway on Tuesday, March 5th. So you'll have until pretty much the end of the week after spring break. That's the way it'll work, because we've got about a week before spring break, about a week after spring break. So you'll have until, we'll just make it easy and say the Friday of the week after spring break, so that would be the 29th. So that's how long you'll have to come and retake it, and you come and retake it every single day. Here's the deal. Students who come and retake it like they're supposed to pass. So even if the first time you take it you get a 4 because you made errors all over the place, you forgot this, you forgot that, whatever. If you come and you consistently retake the quiz, you will get to the point where you have 18 right, and once you do, you get full credit, 50 out of 50 points. This is a huge grade booster, huge. It's worth half a test, right? Huge. The only time I have students who do not end up with full credit on this and get some sort of a partial credit amount, and the partial credit's described in the syllabus, is because they don't come in and do it, or they wait too long to try, okay? Please don't do that. We will be having an exam over this material on the 12th, which is the Tuesday before spring break. So, and even if we, for some reason, can't quite get to that point, it'll be the Thursday before spring break. We're having the test over this, and you have to know this material for that test anyway. So I would advise, let's get it done before your test, or at least attempt it quite a few times if needed be, or whatever, before your test, so you don't miss points in your test too, because you will miss points in your test if you're still not understanding the material on the gateway. Okay, any questions about the gateway that I can answer? Nope.
I have a question about chain rule.
Okay, yes, question about chain rule.
Okay, so if we have a chain rule that's 7 in parentheses times the sine of 3x squared.
I'm going to write this down in just a second. Sine of what?
3x squared and then squared on the outside, like in between the 7, like 7 at sine and then the outside.
Like this?
Yeah.
Yeah, that one? So
Okay.
the whole thing's squared too. Yep.
So we take the 2 and make that 14.
Mm-hmm.
Okay. Times the derivative of sine, which is cosine.
Not yet.
Oh, yeah.
First you'd rewrite the sine of the 3x squared. Okay?
And then
That's the outside. Then you do the derivative of sine.
cosine of 3x squared times 6x, correct?
Yep. Yep, and then again on a gateway you wouldn't do anything else, but on a regular homework assignment or something, web assign, quiz, question, test question, you clean it up. Okay? Yep. All right.